Hi, I'm Dr. Bob Sottilare. I'm the Chairman of the Board and Executive Director for the Adaptive Instructional Systems Consortium. The AIS Consortium is a not-for-profit alliance under the IEEE Industry Standards and Technology Organization, and the consortium was formed in December 2020 as a 501c6 business association. Our mission is to promote the development and adoption of effective AIS solutions and to support the industry and organizations that produce them. I've been in the learning sciences and technology field for nearly 40 years. I have a doctorate in modeling and simulation from the University of Central Florida with a focus in intelligent systems. I'm also the Director of Learning Sciences at SWORD Technology in Orlando, Florida. Sometimes I'm known as the father of GIFT and adaptive instructional architecture. I'm the founding chair of the AIS conference and founding chair of the IEEE Project 2247 AIS working group, which seeks to produce standards and best practices for AISs. So thank you for the opportunity to talk to you a little bit about adaptive instructional systems. So the first question is, what are adaptive instructional systems? So AISs guide and tailor training and educational experiences for both individual learners and teams. They've been proven to be highly effective teaching tools that can accelerate learning. AISs include instructional strategies and policies that accommodate the individual differences of people to facilitate knowledge acquisition. There are also technologies, computer-based systems, tools, and methods that guide learning experiences by tailoring instruction and recommendations based on the goals, needs, and preferences of each learner and the context of domain learning objectives. And finally, there are products in the marketplace that use artificial intelligence and other advanced technologies to help people learn. So what are the typical parts of an adaptive instructional system? AISs are composed of four common components or functional parts. One is a model of the individual learner or the team, a model of the instruction, a model of the domain or topic that is being studied, and an interface model to enable learner or learners to interact with the AIS. Okay, so how is an AIS different from an intelligent tutoring system? Well, intelligent tutoring systems are actually a type of adaptive instructional system. And the different types of adaptive instructional systems include ITSs, which have many different types, recommender systems, which provide guidance or mentoring functions, expert systems might fall in here, and then intelligent media kind of group together the remaining types of adaptive instructional systems and tools. So what are some examples of AISs that are currently in use? Here's a handful of different products and frameworks that are representative of what's in the marketplace. Mathy is a commercial AIS developed by Carnegie Learning that supports the tutoring of mathematics topics. AutoTutor is a conversational tutor and tutoring framework developed at the University of Memphis. The Generalized Intelligent Framework for Tutoring, or GIFT, is an open source tutoring architecture developed by the U.S. Army that supports individual and team training. The Squirrel AI Adaptive Platform provides a student-centered, intelligent, and personalized education experience for learners. And the Funicole is a commercial AIS developed by DigiPro and used to teach a variety of K through 12 subjects. What are some examples of current AIS research topics? These research areas include significant investments to improve the accuracy of learner and team state classification using AI, expanding methods to exploit learner data and improve learning outcomes, automating elements of the AIS authoring processes to reduce the time, cost, and skill required to develop these systems, including AI-guided adaptive course creation, automated scenario development, automated integration of AISs with external systems like training simulations and serious games, automated creation of synthetic populations from source data, expanding interfaces for learners with disabilities, and enhancing self-improvement of AIS instructional models with experience. So what challenges need to be overcome to see more widespread adoption of AIS technologies? AIS technologies have been applied to various populations and topics of instruction that include pre-K, like alphabet and counting, K through 12 and college, math, deductive reasoning, and science topics, adult learning, including literacy, job training and retraining, and military readiness, including pilot training. The technology has been experimentally proven to be effective, so in my opinion, the primary challenges are cultural and economic, and I'll talk about each of these. The cultural challenge is primarily the adoption by teachers, where some teachers see AIS solutions as competitors for their jobs. We, the AIS Consortium, need to work with teachers to assure them that AIS technologies are a teaching tool that works for them to reduce their workload and allow them to focus on more difficult teaching challenges. The economic challenge is the availability of AIS technology has been limited by its affordability, but this is changing, and AIS solutions are emerging that are accessible through more prevalent and affordable devices like smartphones, and we in the AIS Consortium should continue to explore opportunities to develop low-cost alternatives to our current product lines and solutions and provide improved access to disadvantaged groups. So what technologies, tools, and methods need to emerge to solidify AISs as instructional tools of choice? Here are 3 areas that I believe are significant to AIS researchers, designers, developers, and providers in the marketplace. Authoring methods. I mentioned this earlier, but it's worth mentioning again. AISs currently require high-level skills to design and create them, and the AIS authoring process can be very tedious. Making AISs a more affordable and practical means by automating authoring processes will make it easier for subject matter experts to create adaptive instruction without knowledge of instructional design or computer programming. And this should be a goal. Competency modeling methods. So we should seek to expand learner modeling to include longitudinal learner data in addition to the near-term data that's collected during adaptive instruction. And finally, causal modeling methods. Improving causal modeling methods will enable AISs to identify and act on root causes for both positive and negative learning outcomes, and this will greatly improve the quality and effectiveness of AIS interventions during instruction. So what is the AIS Consortium's role in influencing the adoption of AIS technologies? The consortium was created to promote the development and adoption of effective AIS solutions. And we feel we can make our greatest impact by facilitating research and development through 3 activities. The first is bootstrapping. This is identifying and creating methods to make it easier for researchers and developers to jump in and create experiments and products. Our resource repository initiative was started to support bootstrapping, and our outreach committee will be bringing AIS enthusiasts together at shared events, conferences, hackathons, and tutorials. The second activity is evaluating and certifying. IEEE continues to develop AIS standards and recommended practices, and the AIS Consortium has taken on the task of creating evaluation and certification processes to test adherence to those standards. We believe this will help build public trust for the products that are being developed. And vision. Finally, I believe the AIS Consortium should be a leader in understanding state-of-the-art and state of practice and setting a vision for improving future AISs and AIS capabilities. And we hope you'll join us in that mission.